Alright, what's going on, you guys? Another LeetCode video today. This one is called Pacific Atlantic Water Flow. So we're given an M by N rectangular island that borders the Pacific and Atlantic Oceans. So the Pacific Ocean is going to be on the left and top, and the Atlantic Ocean is going to be on the right and bottom. Each cell in this grid is going to correspond to a height above sea level. So basically, the island is going to receive some rain, and the rainwater can flow, with horizontal or vertical adjacency, so north, south, east, or west, if that cell's height is less than or equal to the cell's current height. So basically, yeah, water can flow from any cell adjacent to an ocean into the ocean. So with that in mind, they want a 2D list of coordinates that basically denotes which cells can have water flow into both the Pacific and Atlantic Oceans. So it's a pretty wordy problem statement, but basically what they mean is they want basically just a list or a vector of cell coordinates. So a vector of cells, which are the cells that have some path that where the water can flow to both the Pacific and the Atlantic Ocean. So there technically only needs to be one path to the Pacific, one path to the Atlantic, but there's got to be both. And if that's true, then the cell should go into the result vector. So let's just look at this example a little bit, so we can see that every cell that they highlighted here is going to be able to flow into both oceans. And so let's just look at this 5. We can see that this 5 can flow into the Pacific a couple ways. Could either go this way or this way, because notice this 4 is less than the 5, the 2 is less than the 4, so on and so forth. It's basically decreasing, right? You want a decreasing path, or a path that has the same heights, right? So 5, 1, 1, that counts as flowing into the Atlantic. And if we looked at this 2, we can see that okay, this is there's no possible way this 2 can flow into the Atlantic, so therefore it's not included into the result, right? We could flow into the Pacific. This 2 is not greater than this 2, right? So we could flow this way, but there's no way we can flow into the Atlantic, right? And this 3 is going to be greater, so water cannot flow this way. Same with this 4, can't flow this way. We could try to go around, right? You can imagine a case where it kind of loops around, but there's no possible way we can do that. So we're gonna have to do some kind of depth first search to solve this problem. So an important thing to consider, right, is you might look at this problem at first. Say you're looking at this 4. Just disregard the values of the heights. This is just an example. Say you're looking at like this cell here. Now your gut instinct might be to just check, okay, can it flow this way into the Atlantic, and then that's all you have to check. But actually you might have something where the water has to flow like this to get into the Atlantic. So we've got a depth first search in all directions, right? So that's one important idea. Now there is a kind of a trick where we can solve this problem really easily. There's many ways you can solve this, but I find that this is the most, basically the cleanest way to solve this problem. So, and that is, we're basically going to seed our depth first search just from the edges of this grid, right? So we're going to seed a depth first search from, and it's going to be a little bit different for the Pacific bordering cells and then for the Atlantic bordering cells. But let's look at the Pacific bordering cells first. So if we seed our depth first search, basically what we're going to want to do is basically just mark every cell in a set that's specific. We're going to have 2 visited grids, right? One for the Pacific and one for the Atlantic. And we're basically going to just see how far we can get inland before we stop, right? And we're going to go kind of backwards. Instead of starting like at this 5 and looking for cells that are smaller, we're just going to look for cells that are larger. And we're going to stop when we get to a cell that's smaller, right? Because that means water can't flow outwards. So let's take a better look at that. So we're at this 1 here. We're going to try to depth first search, basically. Let's actually look at this 2, because this 1, we would only be basically just traversing these cells, which we're also going to see to depth first search from, right? So let's look at this 2. All right, we're going to try to go down, and we can go down. So let's circle that. And actually, the way I'm going to do this is make these circles a little bigger, because I'm going to want to circle the entire region when we're done with this. So we see this 2, we're going to depth first search downwards. It is not less than the 2. We see this 4 is not less than the 2. So we circle it. We see the 7. It's still not less than the 2, right? So circle it. And finally, this 1 is going to be less than the 7, so water cannot flow this way, right? So we're going to stop here. Okay, but we would also, search this way, right? And we see the 6 is less, so we stop here because water can't flow this way. We see this 1, we stop here because water cannot flow this way, right? So that's pretty much it for this part of the depth first search. So we're basically just looking for every cell where water can flow into the Pacific. That's what we're doing right now. So we're going to seed another depth first search from this 2. We're going to go this way. This is valid. This is valid. We're going to stop here, right? We've already visited this, so we don't need to look at that. We look at this 3, it's less, so we're done there. Okay, so we're going to start from this 3. See, this 4 is good. Okay, this 3 is too small, so we have to stop there. But we can search this way. So we also have to do a depth first search on all of these cells, right? So this 3, the water can obviously flow into the Pacific. We've already searched this 2. We searched this 2. Can obviously flow into the Pacific because it's adjacent. We search this 5. This 1 is smaller. Water cannot flow this way. So we stopped here. Okay, so this is all of the cells pretty much. I also forgot this 5, but this is pretty much all of the cells where water can flow into the Pacific, right? So that's basically what we were looking for. So there. But we basically just want to do the same thing for the Atlantic. So let's do that. So let's get a different color here. Let's get green. Okay, so we're basically going to do the same thing. We're going to seed our depth first search, and you might begin to notice a pattern here. It's like basically every cell where the water can flow into both the Pacific and the Atlantic is going to go in our result vector. We're basically looking at the intersection between 2 sets. We're looking at the intersection between, we can call this Pacific set A and this Atlantic set B. And we're just looking for the intersection of those sets, right? That's going to be our solution. So anyways, yeah, we look at this 1. That can flow to the Atlantic, so it's good, but water cannot flow, or actually it can, right? So it can flow this way. Okay, so we continue our depth first search. This 4 is less, so water can't flow this way, right? So we stop searching there. Same with this. The water cannot flow. This 6 is less than the 7, so it cannot flow this way, right? So keep going. This 1, we'll do our depth first search this way. We see this 5, is greater, so that's great. We go this way. This 3 is smaller, so we stop. 4 is smaller, we stop. And we're only concerned with cells we visited that are green, right, for the Atlantic, because we're literally looking for intersections here. So we're disregarding the cells we visited for the Pacific for this DFS. So we have this 2, this 4 is good, this 3, we actually can't go this way, right? Water can't flow this way. So But we already visited this 1, this 5. Water can go this way, right? So we circle that one. I mean, it would already be circled, right? Anything that's adjacent is circled. So these are going to be circled too. In terms of the DFS, we can't go this way. It's got to be greater than. Can't go this way, or we can actually go this way because it's equal to. But this 3 is less, so we stop there. This 1, this 3 is greater than this 1, so this is also fair game. So basically what we're looking at now is just the intersection of these sets, right? So let's go ahead and just use those coordinates and then ensure that this is the correct answer. So we have let's see, 0, 4. Let's see, we have 1, 3, 1, 4. Let's see, that's going to be 2, 2. This is 0, 1. That's going to be 1. Let's see, or actually no, 0, 1, 2, 3. So 3, 1. And then finally we have 4, 0. Okay, so that's 1, 2, 3, 4, 5, 6. This is the exact same example as this, so let's go ahead and check that. Looks like we are missing 6. Let's see, what did we do wrong here? Well, this 5, we see this 6 is greater than this 5, so this counts also. So we would have a, let's see, because the depth first search would work this way, right? So that's why that one should have been added. So we have a, let's see, 4, let's get the right color there. 4, or no, it's going to be 3, 0. So it's 1, 2, 3, 4, 5, 6, 7 different cells, right? So, and there's 1, 2, 3, 4, 5, 6, 7 different cells. So this appears to be correct, right? We have those, yep, so that looks correct. So in a nutshell, yeah, that's basically the approach, right? We're looking for cells that can flow into the Pacific and cells that can flow into the Atlantic, and then we're just taking the intersection of those cells, right? And it's as simple as that. So the time complexity is going to be big O of, let's see, big O of n times m, right? Because we're doing a depth first search, basically, which could potentially, cover the whole board. At most, we're visiting each cell twice, right? For these intersections. So yeah, so big O of n times n for the time complexity, and then the space is just going to be big O of, let's see, we're using 2, so we have 2 times n times n times m, right, for those 2, visited, basically marking, what cells we visited for the Pacific and the Atlantic. And then we also have a recursive call stack for DFS, right? But that in the very worst case, it's going to be n times m, right? So we just add another, that's just a constant. It would be like 3n times m. So we can just say n times m for the space complexity also. So yeah, let's go ahead and get into the code for this problem. So firstly, we want those 2 vectors of Booleans to basically mark the cells where the water can flow into the Pacific. So we'll say Pacific, what's a good name for this? We can say Pacific visited, right? Or Pacific flow. These are basically all the cells where the water can flow into the Pacific Ocean. And we have to have, the correct size for this grid, right? It's going to be the same as heights. So to do that, we'll just pass in, let's give some more room here. It's going to be a long line. So it's going to be heights dot size. And then we're going to have a vector of Booleans of the number of columns size, right? So that'll be height or heights 0 for the columns dot size, and then each of those values are going to be false to begin with, and then we're going to do the exact same thing because we want a grid of the same exact size for the Atlantic, for cells which can flow into the Atlantic Ocean. Okay, so now we're just going to, we want to seed our recursion at the edge of the grid, right? So the way we can do that is we can just say for an I equals 0, first let's seed the recursion for the rows, right? So this will be for the left side basically and the right side of the grid. So I is less than heights dot size I plus plus, and then we're going to basically say, okay, well, we want to do our depth first search. I'm just going to overload this function for our DFS. So we'll say Pacific Atlantic. We need to call this DFS on, let's go ahead and get the, we're going to want to call it twice, right? Because we basically have to call it once for the left side and once for every element on the right side. So that I is going to go in first. This value will just be 0 all the way across for the beginning, and then for the end it'll be heights heights 0, right, for that last column for the right side, -1, right, for the final index there. And then we're gonna have to pass in a couple more things. So we need to pass in the heights, right? And then we also need to pass in, let's see, for this, right, for when j is 0 and we're on the left side, we're gonna be bordering the Pacific, right? So we wanna pass in the visited cells for the Pacific, right? We're searching for where the water can flow into the Pacific for this call. And then for this call, it'll be the opposite, right? Because it's the right side, so it's the Atlantic. So it's going to be Atlantic visited. Okay, and that's pretty much it for the left and right side. We've also got to seed the DFS for the top and bottom, right? So we'll just say J, and that's going to be for the number of columns, right? J plus plus, and then we're going to have J for the J coordinate, and then for the I coordinate, right? When we're at 0, or we're at the top of the top of the grid, it's going to be Pacific, right? So we want Pacific visited, and then down here it's the Atlantic visited for the bottom of the grid. So, and that'll be heights dot size -1 for the final row index. Okay, so now that we've seeded the DFS, there's basically one more thing we need to do, right? I mean, we've got to obviously implement the DFS. We'll do that in a second, but we basically want to check where the cells can flow into the Pacific and the cells can flow into the Atlantic. If both are true at the same cell, that means it can flow into both. So we add that to our result vector. So we're going to say vector, and it's actually a vector of integers, right? Because each cell has 2 coordinates, and we can see just because they literally explicitly give the return value right there. But anyways, yeah, we'll just call that res, and then we're just going to loop through the entire grid. So I equals 0, I is less than coordinates.size for the rows, I++, and then j is less than heights 0.size for the columns. Okay, and then we basically just say, okay, if Pacific visited ij, if that's can flow into the Pacific, so if that's true, and Atlantic visited ij, if that's also true, if it can flow into the Atlantic, then we're just going to say res.pushback on that cell coordinates. So res.pushback ij, right, just those coordinates. And then we can just return that result at the end, right? So let's go ahead and code that DFS, right? So it's just going to return void. We're going to overload the Pacific Atlantic function, right? It'll just take more parameters. So it'll have the indices, so I and j, and it'll have the heights, right, by reference. So let's just copy and paste that. And then it's also going to have just one of these grids, one of these visited grids, depending on whether we're checking for Pacific flow or Atlantic flow, right? We're doing those separately. So we'll just call this visited. And obviously that's going to be by reference because it's kind of like a global. Okay, so first let's check, if we've already visited this cell. So visited ij, we're just going to go ahead and exit our DFS, return, right? Because there's no point in doing work we've already done. Also, we don't want to search forever. So anyways, yeah, visit ij. If we've already visited it, we can just return. Now we want to mark this cell as visited. So visited ij, we'll just set that to true. And now we need to call our depth for search, right? So firstly, we need to ensure that we're remaining in bounds. So we need to make sure I+1 is less than the number of rows. And we basically want to make sure the next cell is greater than this cell, right? To ensure water can continue flowing towards us, pretty much towards the Pacific. So we'll say, so heights I+1 j, so the next cell has got to be basically greater than or equal to this cell, heights, to ensure the water can, flow into the, if this was the Pacific, into the Pacific. If it was the Atlantic, same thing, into the Atlantic. So we're just trying to mark all the valid cells as, visited for their respected visited vector of vectors. So yeah, if both of those things are true, we can just call the DFS. So Pacific, Atlantic, we pass an I, or really it's I+1, j, and then heights, and then visited. So, and then we've got to do that for all 4 directions. So just paste that 4 times. I-1, and now we're simply just adjusting these coordinates. So we're decrementing I for this. And then when we're decrementing I, it's got to be greater than or equal to 0 to stay in bounds, right? In the negative direction. Okay, so for j+1, we're checking the columns, right? Instead of the rows, we're ensuring it's in bounds in terms of the columns. And then adjust the coordinates. +1, and then there's one more, right? We've got to decrement j. Again, when we're decrementing, it's greater than or equal to 0 to ensure we're in bounds in the negative, when moving in the negative direction. j-1. And that's pretty much it. So at this point, we have marked, every cell respectively, and then we would have checked the intersection and then returned the result. So that's pretty much it for the code. There's quite a bit here. So let's see if there's any bugs. So nope, looks like we're good to go. So hopefully this video helped you understand Pacific Atlantic water flow better, and depth first search better. If it did, leave a like and subscribe, and I'll see you guys in the next video. Peace.